So we talked about things being differentiable. Well, things are differentiable if they're continuous, right? They have to be continuous, and they can't have a cusp. So this one here has a cusp, and a cusp would create a vertical tangent, and a vertical tangent would be 1 over 0, which is undefined, correct? So this is not differentiable. Whenever you have a cusp, not differentiable. Why is this one not why is this one not differentiable? Because it's not continuous. It says it's breaking the graph. I'm like, why is this one not continuous? And it says it right here. All right, and then this one, you end up having a very, very vertical line, hence a vertical tangent, and therefore not differentiable. Okay? So you have to be continuous to be differentiable, and you can't get any vertical tangents. Right? Max and mins are horizontal tangents, which is a slope of 0. Totally good. You can't have a slope of 1 over 0, which is undefined. Okay? This would get me a vertical tangent, 1 over 0, undefined, and so would this. A cusp or a corner. All right. That was just a side note. Rolle's theorem. What the heck is Rolle's theorem good for? Okay. So, f is a function defined by a closed interval a, b, just like we did for intermediate value theorem, right? We have an interval of a closed interval on an equation. So f is continuous on AB has to happen, which is what had to happen for intermediate value theorem, right? It had to be continuous. So what is it for Rolle's? Now the catch for Rolle theorem is that it also has to be differentiable. So there can't be any cusps, there can't be any vertical tangents, and the graph has to be continuous, which we covered in A, right? If it's continuous, that's already a good thing. Now, the other thing for Rolle's theorem is that your endpoint, f of A, has to equal f of B. Yeah? Yep. All right. We're not going to keep talking, right? Because that's just going to annoy me. Okay. F of A has to equal f of B. So your endpoints have to be equal. Then there's at least one number C in the open interval A, B for which f prime of C equals 0. So if your endpoints, f of A equals f of B, then what does that mean? How do you get an f prime of 0? F prime of x equals 0. When does that happen? Maxes, mins, points of inflection, correct? So if I have, for example, an A, f of A and an f of B that are the same, and the graph is continuous and differentiable, which means not just a straight along drawn along line. A straight drawn along line wouldn't work. I'm going to have to do something at some point and come back down and come back up and make a min. Or I'm going to have to go down and come back up and make a max, correct? So if, when I fill in my endpoints, I get the same y value, the graph is continuous and it's differentiable, there exists a min or a max, which is what it's saying. There exists a c, an x value, where there's a min or a max, a critical number. That's the first derivative. That's Rolle's theorem. Okay, so here it says, find the x-intercepts of f of x equals x squared minus 5x plus 6. So let's find those first. So, what are the x-intercepts? We do f of x equals x squared minus 5x plus 6. When you hear x-intercept, what should you immediately think? Y equals 0. So we're going to get 0 equals x squared minus 5x plus 6. How do we get x-intercept? Starts with an F. Rhymes with actor. Factor. Wow. Wow. You guys like passed 30-1. Like some of you annihilated 30-1. Factor wasn't there. All right. So what multiplies to give me 6 and adds to give me negative 5? What times what equals 6? What plus what equals negative 5? A negative 3 and a negative 2. X minus 3, shh. X minus 2. Yes? Why are we finding x-intercepts for Rolle's theorem? Why do you think that would be helpful? The easiest because it gives you, x-intercepts give you the same what? Y value, correct? And Rolle's theorem needs 2 of the same y values. We agree? If I have 2 of the same y values, then I can just say that there exists a c between them. That would get me a horizontal tangent, right? Could I do y equals 1 instead of y equals 0? Yes. I could do y equals 1, or I have to use quadratic formula. I could do y equals 2, I could do y equals 3, I could do y equals 4. But as long as the graph cuts through, that's good. So I'm going to do x-intercepts because it's the easiest. So x equals 3 and x equals 2. I found two values, 3 and 2. We agree? And of those two values, I have 3, 0, 2, 0. Is this graph continuous? Yes, it's polynomial. So we're going to say the graph of f of x is continuous since f of x, you can say it's quadratic or polynomial. So you have to state continuity for Rolle's theorem. You have to state differentiability for Rolle's theorem, right? It's a quadratic. Quadratics are differentiable, so are polynomials, yes? So f of x, the graph of f of x, let's say the equation, I guess, of f of x is differentiable. Can we put this together in one sentence? Continuous and differentiable because it is a polynomial? Yes. Okay, let's go through and see what it actually wants us to do. So here it says, find the x-intercept of f of x and show that f prime of c equals 0 for some c belonging to the interval formed by the two x-intercepts. So Rolle's theorem states it has to be continuous. We already stated that. It has to be differentiable. We already stated that. It has to have two y values that are the same, which we just found. Correct? So we can say, using Rolle's theorem, f of 3 equals 0 and f of 2 equals 0. Therefore, f of 3 equals f of 2. There exists some value c where f prime of c equals 0. So we know that there's going to be some horizontal tangent, because if there's x-intercepts, at some point I'm going to have to curve and come back. Correct? And in particular, because this is a positive quadratic, we know there's a minimum. Concave up, right? We know there's a minimum somewhere between those values. It's going to have to curve and come back. Right? That's the reason why Rolle's theorem works, because it's continuous. Differentiable. Differentiable means I know that there's not a cusp. If this was like a absolute value function, I could have a cusp. It might not be differentiable. All right. It wants us to find c. How do I find c? F prime of c equals 0. We've been doing this the whole time. We just find the first derivative and set it equal to 0 and get the critical number. Correct? Yep. So let's try it out. So f prime of x equals 2x minus 5, but they don't want f prime of x, they want f prime of what? C. F prime of c equals 2c minus 5, and they want where f prime of c equals what? 0. So I want 0 equals 2c minus 5. So 2c equals 5, so c equals 5 halves. So intermediate value theorem will not be on this test, but there will be a Rolle's theorem question, and there will be a mean value theorem. Yeah. Test is Wednesday. Yeah. After this, I have a little review to practice and practice questions. And then tomorrow we're going to go through all the different things, what's on it, remembering the steps. All right. Shh. The next one, so Rolle's theorem just shows that there exists a max or a min, a critical number between values if you have y's that are the same and the graph is continuous and differentiable. Mean value theorem, what does mean mean? What does mean? Average. Average, right? This could be like an average value theorem. Let's see what the heck it means. So, let f be a function on closed interval. Once again, f has to be continuous and differentiable. Cool thing about your test on Wednesday is if I ask for Rolle's or mean, you have to state that it's continuous and differentiable between those values, right? They're the exact same thing. That has to be stated if I'm asking you to do rolls or mean. Yes, Kai. Yes. All right. Then it says here, then there is at least one number c in the open interval AB for which f prime of c equals the slope. So what does that mean? So here it says, verify the function f of x equals x cubed minus 3x plus 5 minus 1 to 1 satisfies the conditions in the mean value theorem. So first off, we have to state it's continuous and differentiable. Yes? Why is this one continuous and differentiable? It's a what? Why is it continuous and differentiable? It's a cubic function or a polynomial. You can either say cubic or polynomial because both of those are continuous, always, correct? So, we're going to say the graph of f of x, you can say is a cubic function or you could say is a polynomial function, both of which work. Is a polynomial function and therefore continuous and differentiable. Okay. Rather than memorizing, I want you to understand why the mean value theorem works. So, can everyone graph the graph of x cubed minus 3x plus 5 from negative 1 to 1, please? I want you to sketch a little graph from negative 1 to 1, please. Sketch it. So that's the graph that we're specifically looking at. Now everyone put your pencils down. I want to show you what the mean value theorem does. So if I gave you something like this, say this was the graph I gave you, and I resulted it from here to here. Okay? What we're doing is we're technically, the mean value theorem is this. F prime of C, you don't have to write this down, I'm just proving a point. F of B minus F of A all over B minus A, which is a fancy way of saying y2 minus y1 over x2 minus x1, which means this is slope. This is just grade 10 slope. Do we agree? Everyone's paying attention to understand mean value theorems and memorize? Memorizing scares me? All right. So if we're finding the slope between the endpoints, which is all we're doing here, correct? This here is just finding the slope between the endpoints, this right here. Do we agree? If I do the slope between the endpoints, I'm finding that slope, let's say, yes? All the mean value theorem states is that there exists another spot where that slope exists. So a tangent slope, because f prime of c, this is tangent slope, right? Because anytime you're doing f prime, that's a tangent slope. So there exists somewhere along this graph, could be even here maybe, here, where that slope will end up being the same as this one. Or even down here possibly, that slope is the same. We agree? You're finding all the c values on the graph. There could be more than one, there could only be one, there could be three, we don't know. You're finding all the c values on that graph between those values, with limited domain, but the tangent slopes are the same. So this one in particular would have two spots, right? And I'd have to find the c. The c meaning the x where that exists, those x values. Okay? So going back to this question, they want us to find those. So first off, we know if they ask us for the mean value theorem, we have to do f prime of c equals slope. I'm writing it out that way because that's literally all it is. The formula seems really, really confusing when you have f of b minus f of a over b minus a. It is slope. It is grade 10 slope between your endpoints. That's it. So what are my endpoints? F of negative 1 equals 7, and f of 1 equals 3. True? So how can I write that another way? Negative 1, 7, 1 and 3. x1, y1, x2, y2. Literally grade 10 slope, correct? So we're just trying to find the tangent slopes that will be the same as the actual slope between those endpoints. That's it. So let's find the slope first. What is slope? 3 y2 minus y1, 7, over x2, which is 1, minus a minus 1. So it's going to be negative 4 over 2, which is negative 2. Do we agree that the slope between those endpoints is that? Have you learned anything new at this point? It's grade 10 slope between two endpoints, right? That's all I did? So, they want f prime of c equal to negative 2. They want to know where the x values are that would get me a slope of negative 2. A tangent slope of negative 2. Right? Can I fill in f prime of c? F prime of anything is really easy to find now. It's just the first derivative, right? What is the actual equation of the original? The equation of the original, f of x is equal to x cubed minus 3x plus 5. We want f prime of x. What's it going to be? 3x squared minus 3. And they don't want f prime of x, they want f prime of c, which is the exact same equation but with c's. That's it. Do you agree? So f prime of c equals 3c squared minus 3. And that's going to go in here, because that's what f prime of c equals. 3c squared minus 3 equals 2. What are we going to have to do now? Solve for c, right? Add 3. 3c squared equals 5. Yeah, that's going to suck if I kept going. Good catch. 1. C squared equals 1 over 3. And then I square root. When I square root, what do I get? Positive or negative. Yep, I just said positive. So C equals positive. Grade 10, you're taught this, remember? You're taught that if you have a radical and one of the numbers is perfect squares, you can take the square root of both of them separately. Remember we talked about this? Yes? No? Yes? So if I have like square root 1/3, I can actually write that as square root, 1 over square root 3. I don't know why I wrote it so aggressively, which is 1 over root 3. And you only split them when one is a perfect square. So like in grade 10, you'd be given square root 100 over 7, let's say. Well, you're not going to leave it like that. You could rewrite it as 100 over square root 7, which is 10 over root 7. You only split it when one of them is a perfect square so that you can get rid of it, right? Taught that in grade 10. You're all like, no, but you were. Okay, good talk. All right. I don't even know where I just was. Here we are. So this one's going to be positive. I want to keep with my words. Positive 1 over root 3 and negative 1 over root 3. What is root 3 over? What is negative 1 over root 3? Type in your calculator. What do you get as decimal? Negative 1 over root 3. Type it in. What do you get? Negative 0.577. Does that fit in my restricted domain? That you always have to check. Sometimes you're going to get C values that actually don't fit. Right? Like you might get a C value that is outside of the domain. That would work because we might not have a restricting our domain, right? But do both these work? Yes. So both of these work. And they are good. All right. I'm going to give you 2 questions for your textbook. One on mean, one on rolls. Okay, page 289. Number 1 is rolls. Number 9 is mean value theorem.